everyone. This video would focus on the parts, the two cases, and the equations of hyperbola with center at 0, 0 or at the point of origin. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Let's take the first case of hyperbola, the horizontal hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus. And there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now, let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis that is from one vertex to the other vertex is a formula of 2a, while the length of the conjugate axis that is from one co-vertex to the other co-vertex is 2b. Now, the equation that relates all these three lengths here, a, b, and c, is c squared equals a squared plus b squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. We get the center. We have the two vertices. We have the transverse axis. We have the co-vertices. We have the conjugate axis. We have the two foci. We have the two latus rectum. We have the two asymptotes. Again, we use the rectangle to approximately draw the asymptotes. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We have the a, which is the distance from the center to the vertex. We also have the b, which is the distance from the center to the co-vertex. And we have the c, which is the distance from the center to the focus. Again, length of the transverse axis is 2a. The length of the conjugate axis is 2b. And the formula that relates a, b, and c in a hyperbola is c squared equals a squared plus b squared. And again, the eccentricity of a hyperbola has a formula of c over a. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now, please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. If you find this video helpful, hit like and subscribe for more math videos. See ya!